Welcome to Hope Academy. My name is Mr. O, and today I'm going to be going into depth around the concept of geometric distribution. If you are curious about more around the binomial distribution, feel free to watch the prior videos where I explain in depth on binomial distribution, but today we are focusing on geometric distribution. As I mentioned in a prior video, geometric distribution is the concept that we take a bunch of trials and we get a bunch of quote-unquote failures until we get our first success. That's the idea behind a geometric distribution. And also be aware that this equation is the equation for a geometric distribution is not provided on the exam, but has very similar structure to a binomial distribution. If you're curious how that's possible, feel free to watch the first video based on these series, and where I do explain how that comes about. But that being stated, I'm going to go ahead and explain that this concept today, I do have actually 3 questions to cover, because I feel that these 3 questions will help encapsulate what to expect for geometric distribution when it comes to the AP statistics examination. And so I'm going to go ahead and go into depth around this and explain how to go about doing these questions. So I'm going to go ahead and get started. So the most common data collection method in consumer and market research is the telephone survey. A major problem with consumer telephone surveys, however, is non-response. How likely are consumers to be at home to take the call? And if at home, how likely are they to take part in the survey? To answer these and other questions, R.A. Karen and R.A. Peterson directed a study of over 250,000 random digits dialings of both listed and unlisted telephone numbers across the United States. Journal of Advertising Research. The probability of a completed interview was assessed to be 0.084. What is the probability that the five calls must be made before the first completed interview is obtained? Okay. So that was quite a mouthful. Do note that you don't necessarily need to read every single word on the AP Stats exam. I was just reading it for your convenience, but be aware that to save time along the way, you do want to make sure to not read every single word. Just make sure to get the idea or the gist of the work. So the first question asked was the probability that five calls must be made before the first completed interview is obtained. Okay. So what this means is that in that 5 calls, the 5th call is basically my success. That the person finally accepts to take an interview. Okay, and so I do want to identify that 0.084 is going to be my P. Okay, and so when I'm doing this type of question, I need to know my geometric equation. And so right here, my geometric equation, I'm going to provide it right here. It's n minus 1 and P. And I am done. Voila. And so that is my equation for this equation. And so just to plug in the values, as I mentioned, this is 5 calls is going to represent my n then, because this is the total number of calls he takes. The 4 failures basically, and the 1 successful call that made the interview. And so I'm going to plug in the values. So 1 minus 0.084 to the 5 minus 1 times 0.084, which is basically, so I'm going to punch in 1 minus 0.084, whoops, and it's going to be 0.916 to the 4th power times 0.084, because 5 minus 1 is 4, and so I go ahead and do that. Afterwards, 0.916 to the 4th power times 0.084 will equal to 0.0591. 1, because the 4 digits is about good to help me estimate the values to be accurate enough. And so, and it asks for the probability, so the probability actually will be 5.91% chance. So this is my probable chance. It's my probability that it requires me to take 5 calls, being that the 5th caller will be the success, and that someone finally picks up to take an interview. Okay, and that concludes my first problem. So sometimes problems for geometric distribution will come out like this on the AP statistics examination, but that being stated, it's not always the case. So feel free, we're going to go to the next question to sort of break down what other possible questions of geometric distribution could exist. So they say, what is a probability that at least 5 calls must be made before the first completed interview is obtained? So just to create the comparison between A and B, this one says this is just absolutely that, what's the probability that just at 5 we're successful. This one's saying at least 5. That means that this is the possibility when P of n equals to 5. And when they say at least, that means I need to keep going up. That means that it's like the probability of n equals to 6, probability of n equals to 7, and it will go dot dot dot. It will go on infinitely forever and forever and forever. Okay? And so when we're talking about the probability of 5, this is the probability of 5 will actually be what we did up here basically. This exact same equation. So I will write it down. So it'll be 1 minus 0.084, 5 minus 1 to the 0.084, which will equal to 0.0591. I do want to provide you the context as to where I'm going with this. So 1 minus 0.084, 6 minus 1, and then it will be 0.084, and this will equal to 1 minus 0.084 to the 7 minus 1 times 0.084. Okay. And you know, these will end up with their own probability values, but that's not the important case. The idea is that how do we go about adding up all these infinite number possible values where let me show you what actually is occurring. So let me do these two and punch these in. Okay. 0.0455 and this one. I'm just doing a quick computation for you guys right here. If you notice right here. Whoops. I realized that I made a little mistake, so I'll correct that. This should be 0.0455. And this one, let me do the entry. Oops. Okay, let's do 7, 6. That's 5 actually. 5. Will actually be 0.04542. Okay. Okay, so just correcting a little mistake. But the point is that when you what the point is for me doing this is that if you notice, these values are gradually getting smaller. They will infinitely get smaller and smaller and smaller to a certain point, and then we will have an actual, you know, general as close as possible p-value that would exist for this. And so the way you could solve these type of questions is that you actually need to know another equation for this that will help you solve it. So the sum, aka of the infinite going on and on and on, will equal to a over 1 minus r. And so when we talk about a is actually going to represent my first term. And this will represent my ratio. So for this question, my first term is going to be actually the first term of this whole sequence, which is going to be represented here. So this is my a. And so this a value will actually be 0.0591 divided by 1 minus, and that's where the question comes in. What is my r? My r is the multiple that exists here. This 1 minus 0.084 will actually represent my r, because this is my multiplier, right? Every time there's a multiplier of 1 minus 0.084 that are occurring. And so when I'm doing that, 1 minus 0.084 will actually be 0.916, and I'm going to go ahead and write that here. And so what happens is that when I do 0.0591 divided by 1, and doing note, I put parentheses on the bottom so that the PEMDAS rules and such do not mess up my results, will be 0.7036, or aka 70.36% chance that at least 5 calls must be made before the first completed interview is obtained. And that will be my final solution for this question. And so when I'm talking about B is in the context that if we keep going up infinitely, okay? And so just as much as we can go up in geometric series, we could actually also go down. And so my next question to provide you with understanding around this concept is the idea, what is the probability that it takes less than 5 calls before the first completed interview is obtained? So in order to explain this idea of how do we define the next, you know, what is less than and such, the point is that the equation, there's no actual equation for this. It's actually going to be requiring you to do the summation or adding up all the possible values. And so what I mean by that is that first thing first, I want to underline that it says less than 5 calls. That means probability that if I'm successful, these are all based on the concept of success. It's probability of 1, probability of 2, probability of 3 calls until I get my success, and probability of 4 calls until I get my success. So like the prior question that I just did, I would actually have to understand that this is going to be 1 minus 0.084 to the 0, right? Or aka 1 minus 0. wait, actually 1 minus 1, sorry, times 0.084. 1 minus 1 is 0, right? So this, I do want to just emphasize this just in case anyone needs to review a certain fundamental math stuff. But 1 minus 0.084 to 0 power will just be 1. So it will be 1 times this. 1 times 0.084, which is just 0.084. Yeah, it's a little bit long-winded, just in case that will help you that I went about and did that. Okay? And so just to continue on, this will be 1 minus 0.084, 2 minus 1 times 0.084. This will be 1 minus 0.084 to the 3 minus 1 times 0.084. This will be 1 minus 0.084 to the 4 minus 1 times 0.084. Okay? And I could punch in these values. So the way that this question works is there's actually no equation where I could do a summation. Actually, I'm going to actually find all the probability values, these type of values right here, and add them up. And that will actually be my answer for this question. So I'm going to go ahead and just compute this real quick. 1 minus 0.084 to 2 minus 1, which is 1. So I actually could just delete that. Times 0.084. And it will be 0.0769, and now I'm going to keep doing that. So I'm going to create a re-entry, which I could do second enter to get it out, just in case if you want to know that. I'm going to insert to the second insert again. Whoop, second insert. I'm going to put 2 here. Yep. Okay, so this will be 0.0704, and then entry again and change that to 3, and that's going to be 0.0646 to round up. Okay, so 0.0, I'm going to take this value, this value, this value, this value, add them up, and that will be my answer. So it'll be 0.084 plus 0.0769 plus 0.0704 plus 0.0646, and it will end up, the total, when I add this all up, the total answer will be 0.2959, or aka, which is the same equivalent as 29.59%. The chance that it takes less than 5 calls before the first completed interview is obtained. And that concludes my explanation around geometric distribution for today. Thank you so much for watching this video. Please do subscribe to this channel, like the page, comment if you have any questions, or like our Facebook page where we'll continue to build up on this type of content just for you guys. So I hope you have a wonderful day.